So, I want to tell you a story. It's a story about how science is supposed to work. Not by being perfect, because it never is, but by being able to find its own mistakes and fix them. And this story starts with a single statistical tool, a method researchers used for decades to answer some really, really important questions. But that tool had a secret, a tiny, hidden flaw in its very foundation that almost nobody noticed for years. And when they finally found it, well, it changed everything.
Okay, let's make this real. Imagine you're in charge of hiring for a big company. You've got this pre-employment test that's supposed to predict who's going to be a superstar employee. But you have to be sure, is this test actually fair? Does it work just as well for men as it does for women? I mean, getting this right isn't just a good idea, it's a massive legal and ethical deal. And for a long, long time, when researchers needed to answer exactly this question, they all reached for the same tool. That tool is called moderated multiple regression, or just MMR for short. Now, I know that name sounds super technical, but don't worry, its job is pretty straightforward. It's basically a detective. Its whole purpose is to see if a moderator, something like gender or age or ethnicity, changes the connection between two other things, like your test score and how well you actually do on the job. For years, MMR wasn't just one way to check for bias. It was seen as the way. It was the gold standard.
So here's how we're going to break this all down. First, we'll talk about just how popular this tool really was. Then, we're going to pull back the curtain on its hidden and pretty critical flaw. We'll see how often it was going wrong, look at the very real consequences of that, and most importantly, how scientists finally figured out how to fix it. And then we'll see what happens when the science actually changes. First off, you really can't overstate how essential MMR was in this field. Seriously. This wasn't some niche, obscure little technique. It was a foundational method, a trusted standard that was taught in every grad school program and used in thousands of published studies. It was everywhere. And this wasn't just a trend. The major professional organizations actually demanded it. I mean, look at this quote. This is from the official rulebook for the whole field of psychological testing. They were literally telling researchers, hey, you have to use MMR. It was baked right into the standards as the correct and really the only way to do this kind of analysis. But, and this is a huge but, this trusted, required, universally used tool was built on top of a critical assumption. An assumption that, as it turns out, almost everyone was completely ignoring. And when that assumption was broken, it can make the tool's answers totally, dangerously wrong. Okay, here's the technical name, Homogeneity of Error Variance. It's a mouthful, I know, but the idea is actually pretty simple. MMR just assumes that the amount of statistical noise, the randomness and unpredictability in the data, is the same for all the groups you're comparing. So for that hiring test, it assumes the scores for men are just as messy or noisy as the scores for women. But what if they're not? What if the test is a super precise predictor for one group, but a much noisier, less reliable one for another? Well, if that happens, the whole tool just breaks down and the results it gives you are basically garbage. And here's the craziest part. This wasn't some shocking new discovery. The warnings had been there for decades. Statisticians were raising red flags about this way back in 1950. It came up again in a major journal in 1982. The clues were hiding in plain sight in the academic literature. But for whatever reason, the researchers using the tool every single day just weren't getting the memo. So, in 1999, a group of researchers led by a guy named Herman Aguinis decided to figure out just how big this problem really was. They didn't just write another warning paper, they did an audit. They went digging through the top academic journals in their field to see just how often this fundamental rule was being broken. Across a 12-year period, in the 3 most prestigious journals for management and psychology, they found 87 different studies that used MMR for this exact purpose, to check for fairness and bias. Okay, so out of those 87 studies published by the best researchers in the top journals, how many do you think even mentioned checking this critical assumption? Just one. A single study. In every other case, this foundational, absolutely crucial step was just ignored. I mean, that's a massive blind spot, right? So the researchers went even further. For the handful of studies where they could actually get their hands on the original data, they tested the assumption themselves. And the result was just staggering. As you can see here, the assumption failed 58% of the time. Think about that. More than half of these published studies were likely built on a faulty foundation, which means their conclusions could be completely wrong. And look, this isn't just some abstract, nerdy academic debate. When the math is wrong, the real-world decisions that get made based on that math can be terribly, terribly wrong too. This one little flaw can lead to two huge types of errors. The first is what we call a type 1 error, which is basically a false alarm. The bad math tells you your hiring test is biased when actually it's perfectly fine. What's the consequence? Well, you throw out a perfectly good, useful hiring tool and waste a ton of money. But arguably even worse is a type 2 error, a missed problem. This is when the math tells you your test is fair, but in reality it's biased against a group. And so your company just keeps using a discriminatory test, potentially harming people's careers, all while thinking you've done your due diligence. But here's where the story gets really good. The authors of that 1999 paper didn't just point out a crisis and walk away. They built a solution. They gave everyone a clear, practical way forward so that no researcher would ever have to make this mistake again. And their solution was a beautifully simple 3-step process. Step 1, check. Before you do anything else, just test the assumption about the statistical noise. Step 2, choose. If the assumption is fine, great. Go ahead and use the standard MMR. But if it's violated, you have to choose a different, more robust test. And only then, step 3, can you conclude, because now you know your results are built on solid ground. And to make this foolproof, they did something absolutely brilliant. They knew researchers are busy people, so they built and gave away a free, easy-to-use computer program called ALT-MOR that did all the hard work. It checked the assumption and then ran the right analysis automatically. They basically removed every single excuse for not doing the science correctly. So, the million-dollar question, does all this actually matter? Does using the right method really change the answers we get from real research? Well, to prove it, the authors went back and reanalyzed data from old studies that had used the flawed method, and what they found is just stunning. Let's start with a 1995 study by McCall. Using the original flawed MMR method, their analysis found that ethnicity was a significant factor in a workplace dynamic they were studying. They published their results, reporting a meaningful difference between groups. But it was completely wrong. When Agonies and his team reran the numbers with the correct statistical test, the effect just disappeared. Poof! It was a classic type 1 error, a false alarm. The original finding was nothing more than a ghost in the machine, an illusion created by using the wrong tool. Next up, a 1987 study by Latak and her colleagues. Now, their original analysis concluded that gender was not a factor. They found no real difference between men and women in how being accepted by coworkers affected their satisfaction with their union. But they had totally missed the real story. The correct analysis didn't just tweak the results, it completely flipped the conclusion on its head. It uncovered a powerful, significant effect that was invisible before. It turned out that for women working in these non-traditional carpentry jobs, feeling accepted by their coworkers was way more important to their satisfaction than it was for men. This was a critical insight for understanding their work lives, and the flawed method had hidden it completely. So, what's the big takeaway from all this? Well, it shows that even our most trusted, standard scientific tools can have hidden flaws. And ignoring those kind of boring technical details and assumptions can lead to conclusions that are just flat out wrong. But I think the bigger lesson is that the goal of science isn't to be perfect. It's to be self-correcting. It's about building a system where we're always questioning our methods, always looking for our own blind spots, so that we can find our mistakes and ultimately fix them. And that really leaves us with one final big question. It's easy to look back 20 years later and see this mistake so clearly, but it really makes you wonder, what are the hidden assumptions in the tools we all rely on today? In our own jobs, in our own fields of study, what critical flaws might we all be overlooking right now?